Here we have IIT JEE Main's math problem. Okay, let's go to the question. If the set of all A belongs to capital for which the equation 2x square positive A negative 5 times x positive 15 equals to 3a, as no real root is the interval alpha comma beta and capital X equals to small x belongs to z alpha less than x less than beta, then summation of small x belongs to capital X and small x square is equal to. Okay, so the information we have in this question is little tricky. First, let's understand the information clearly. Okay, here we have they have defined their constant a which belongs to capital R. That means a is a real number for which the quadratic equation over here has no real root is the interval alpha comma beta. What do we have to understand from this information? That is, when this small a is a real number and this quadratic equation has no real root, then the value of this a is in the open interval alpha comma beta. That is, a is a real number, and also when this quadratic equation has no real root, this real number a has to be in this open interval. That means a can be a real number between alpha and beta. It can be written as alpha less than a less than beta. Okay, now let me go to the second piece of information over here. This capital X has been defined as a set where each element is x, where x is an integer, because x belongs to z means x is an integer, and also the value of x has to be between alpha and beta. And here the small x belongs to capital X. That means all the values of x are the elements of this set capital X, and we have to plug in the elements of this set capital X over here for this x. So when I plug in the first element of this capital X over here, it will be squared. Then the second element we have to plug in for this x, and that one also has to be squared. Then we have to add them all to evaluate the sum over here. Okay, for that, my first work is to find the value of this alpha and beta, so that I'll be able to define the elements of this set capital X clearly. Okay, now let's try to get the value of alpha and beta using the first information over here. That is, when a is a real number and also this quadratic equation has no real root, the real number a is in this interval alpha comma beta. Okay, now let me take this quadratic equation as it is. It is 2x square positive a negative 5 times x positive 15 equals to 3a. Let me subtract 3a from both sides. Let me do it. When I subtract 3a from both sides, this positive 3 and negative 3 will cancel out. Then I'm getting 2x square positive a negative 5 times x positive 15 and negative 3a equals to 0. Okay, now let me consider the quadratic equation in standard form, that is ax square positive bx positive c equals to 0. This is the standard form of a quadratic equation because we have all the terms on one side of the equation, on the other side we have 0. In order to get the given quadratic equation in standard form, I subtracted 3a from both sides. Now we have all the terms on one side of the equation and 0 on the other side of the equation. Okay, when the quadratic equation is written in standard form, that is ax square positive bx positive c equals to 0, and if the quadratic equation has no real root, then the value of the discriminant of the quadratic equation, that is b square negative 4ac, must be less than 0. Okay, so whenever a quadratic equation has no real root, then the value of this discriminant b square negative 4ac is less than 0. According to the information we have, the quadratic equation over here has no real root. Then the value of the discriminant of this quadratic equation also must be less than 0. That is, b square negative 4ac is less than 0. Actually, b is the coefficient of x and a is the coefficient of x square and c is the constant term. Now, to get the value of b, we have to consider the coefficient of x over here, that is a negative 5. We have to plug in this a negative 5 for this b over here. Then I'm getting a negative 5 the whole square negative 4 times a is the coefficient of x square. Here the coefficient of x square is 2 and c is the constant term. 15 negative 3a is the constant term. Let me plug in. So less than 0. Okay, here we have a negative 5 the whole square. Actually, this is the square of a binomial. So to get the expansion of the square of the binomial over here, let me consider the algebraic identity, that is a negative b the whole square. Its expansion is a square negative 2ab positive b square. Okay, comparing this and this, we have a at the place of a over here and we have 5 at the place of b over here. So in this expansion we have to write a at the place of a over here and we have to write 5 at the place of b over here to get the expansion of this square of the binomial. So let me do it. Then I'm getting a square negative 2 times a times, for b we have to write 5 positive b square means 5 square negative 4 times 2 is 8, 8 times 15 negative 3a less than 0. Then we get a square negative 2 times a times 5 is 10a positive 25. So the evaluation of I square is 25. Now we can distribute this negative 8 to this 15. Then I'm getting negative 1 and 20. When I distribute this negative 8 to this negative 3a, I'm getting positive 24a less than 0. Okay, here what we can do is we can combine the like terms in this expression. So in that case, I'm getting a square. Now we can combine this negative 10a and positive 24a. Then I'm getting positive 14a. Then when I combine this positive 25 and negative 1 and 20, I'm getting a negative 95 less than 0. Okay, now we have a quadratic inequality over here in terms of a. Now we have to solve this quadratic inequality. For that, first we have to factor the quadratic expression we have over here. So for that, we have to multiply this constant of negative 95 by the coefficient of a square. In this case, it's just 1. 1 times negative 95 is negative 95. Now I have to get two factors for this negative 95, so that the sum of the two factors over here is equal to positive 14. I think positive 19 and negative 5 will work. When I multiply positive 19 and negative 5, I'm getting negative 95. When I combine positive 19 and negative 5, I'm getting positive 14, which is a coefficient of a over here. Further, I have to divide both these factors by the coefficient of a square. In this case, it's 1. When I divide both the factors by 1, still I'm getting positive 19 and negative 5. Okay, now we can write the two factors of this quadratic expression. So to get the first factor, we have to write a, and we have to write this one, that is positive 19. To get the second factor, we have to write a, and we have to write this one, that is negative 5 less than 0. Okay, now let me erase the stuff over here. Okay, now what I'm going to do is I'm going to consider this inequality as an equation. So when I consider this an inequality as an equation, then I'm getting a positive 19 times a negative 5 equals to 0. Okay, solving this equation, I'm getting two values for a is equal to negative 19 and a is equal to positive 5. Okay, now let me mark these two values on the number line over here, negative 19 and positive 5 over here. On the left side extreme we have negative infinity, on the right side extreme we have positive infinity. So using these two values of a, we can split up the number line into three intervals. So the first interval is negative infinity comma negative 19, and the second one is negative 19 comma positive 5, and the third one is 5 comma positive infinity. Okay, now we can check each interval with this quadratic inequality, and we have to consider the interval which satisfies this inequality. Okay, now let me take a random value in the first interval. So probably we can take negative 20. So when I plug in negative 20 over here, so this factor will become negative, that is negative 1. And when I plug in negative 20 over here, it will become negative 20, negative 5 will become negative 25. So when I multiply them, it will become a positive value. So positive value less than 0 is false. So the first interval, negative infinity comma negative 19, does not satisfy the inequality over here. So we can reject this one. Okay, now let me consider the second interval, that is negative 19 comma 5. We can choose a random value between negative 19 and 5. So it's obviously 0. We can plug in 0 for a over here. When I do so, I'm getting positive 19 over here. When I plug in 0 for a over here, I'm getting negative 5 less than 0. When I multiply a positive value and negative value, I'm getting a negative value over here. Negative value less than 0 is true. So the second interval, negative 19 comma 5, satisfies the inequality over here. Now let's verify the third interval, that is 5 comma positive infinity. For that, we can take a random value over here. Let me take 6. When I plug in a equals to 6 over here, it will be positive 25. And when I plug in a equals to 6 over here, it will be positive 1 less than 0. So positive value times positive value will be positive. Yeah, positive value less than 0 is false. So the third interval, 5 comma positive infinity, does not satisfy the inequality over here. We can reject the third interval as well. So only the second interval, that is negative 19 comma 5, satisfies this inequality. That means a takes any value, any real value between negative 9 and positive 5. So it can be written as negative 19 less than a less than positive 5, or we can write this one as a belongs to the interval negative 19 comma 5. But according to the question, that is when this quadratic equation has no real root and a is a real number, so the value of a is in this interval alpha comma beta, that is a belongs to alpha comma beta. So comparing this and this, we got the value of alpha as negative 19 and we got the value of beta as 5. Okay, since we got the values of alpha and beta, we can write the values of alpha and beta over here in this set, and we can define the elements of this set. Okay, now let me erase the stuff over here and continue the problem. Let's continue. Here we got the values of alpha and beta. Let me substitute over here. That is capital X equals to small x belongs to capital Z. That means small x is an integer because Z represents integers. And so for this alpha, we can plug in negative 19 less than small x less than 5. So x is an integer and it has to be an integer value between negative 19 and 5. Okay, now we can write the elements of the set capital X over here. So since x is an integer, because x belongs to Z, x is an integer, any integer value between negative 19 and positive 5. So the first integer value we have in this interval is negative 18. Then we have negative 17. Then we have negative 16, and it keeps going. Then we have negative 2. Then we have negative 1, 0, 1, 2, 3, 4. So the last integer value in this inequality is just 4. So these are all the elements of the set capital X, and also these are all the values of the small x we have over here. Okay, now let's start evaluating the sum we have over here. That is summation small x belongs to capital X x square. Already we got the values of this small x, so that the small x belongs to capital X. So here we have the values of x here negative 18, negative 17, negative 16. So now what we have to do is we have to plug in each value in this set over here, this small x, and each value has to be square, and we have to add all the square values according to the summation over here. Okay, now let me plug in the first value over here, negative 18 for x, and I'm getting negative 18 square positive, negative 17 square positive, negative 16 square positive, and it keeps going. Then we have negative 2 square positive, negative 1 square, positive 0 square, positive 1 square, positive 2 square, positive 3 square, positive 4 square. Okay, here whenever we square a negative value, it will become positive, because when we have even exponent, the sign negative sign we have inside the parenthesis will become positive. So we can write this negative 18 square as just 18 square, 17 square, positive 16 square, and it keeps going, positive 2 square, positive 1 square, positive 0 square, positive 1 square, positive 2 square, positive 3 square, positive 4 square. Okay, here we can skip this 0 square because the evaluation of 0 square is 0. It won't make any effect in the sum over here. And also we can split up this given sum into two parts. This is the first part, and this is the second part. We can ignore this 0 square. And also we can write the first part of the sum in the order from least to greatest. Then the least value is 1 square. Then we have 2 square. Then we have 3 square. And it keeps going up to 18, positive 18 square. This is the first part. And the second part can be written as it is, because it's already in the order from least to greatest. That is 1 square, positive 2 square, positive 3 square, positive 4 square. So here there are two parts. I just split up the given sum into two parts. So in the first part, we have the sum of squares of first and natural numbers up to 18. In the second part also, we have the sum of squares of first and natural numbers up to 4. Already we know the formula to get the sum of squares of first and natural numbers, that is summation of n square equals to n into n positive 1 times 2n positive 1 over 6. So here in the first case the value of n is 18. In the second case the value of n is 4. So in this formula we have to plug in n equals to 18 to get the sum of the first part, and in the second case we have to plug in n is equal to 4 to get the sum of the second part. Okay, let me do it over here. Then I'm getting, so in this formula I'm going to plug in n is equal to 18. That is 18 times 18 positive 1 will be 19, and 2 times 18 is 36. 36 positive 1 is 37 divided by 6 positive. And now in this formula I'm going to plug in 4. Then I'm getting 4 times 4 positive 1 is 5 times 2 times 4 is 8. 8 positive 1 is 9 divided by 6. Okay, now what we have to do is we have to evaluate this one. So 6 goes into 6 one times, and 6 goes into 18 3 times. Here both 4 and 6 have the greatest common divisor 2. That is 2 goes into 4 2 times, 2 goes into 6 3 times. So here 3 goes into 3 1 times, and 3 goes into 9 3 times. So when I multiply this 3, 19 and 37, I am getting 2009. And here when I multiply these 2, 5 and 3, I am getting 30. When I add them, I am getting 2139. I have evaluated the given sum over here. Its evaluation is 2139. We find this 2139 in answer choice D. The correct answer choice for this question is D.